All right, so just so everybody can check their stuff one more time, I'll just make sure that you can see how we would have done this for the benefit of people maybe who didn't understand yesterday who weren't here. When we're talking about molar mass, we're talking about using your periodic table and adding up the mass of moles of each atom. The correct formula for hydrogen is H2. That's how we got 2.02 grams per mole as the molar mass. The correct formula for carbon dioxide is CO2. That's how we got 44.01. Manganese, and I just want to point this out, is not the same as magnesium. And I noticed a few people yesterday perhaps reading too quickly and not noticing, but they're not the same. Manganese is Mn, magnesium is Mg. The formula for this is MnCl4, and its molar mass is 196.74 grams per mole. And I think I noticed yesterday the most common mistake was that people were using magnesium. Magnesium's molar mass is 24.31, whereas manganese's molar mass is 54.94. The last example was usually the one that people struggled with because you have polyatomic ions. Just so everyone can see, those are the formulas for the two ions. Ammonium is NH4 positive, phosphate is PO4 3 negative. To make the correct formula, I swap and drop. That tells me that I'll have NH4 inside of brackets and then a 3. And then I'll have PO4. That means that I have 3 copies of nitrogen and 3 times 4, so 12 copies of hydrogen. So if I can just show you the math for this one. I would take 14.01, which is the mass of 1 mole of nitrogen, and I would multiply it by 3. Then I would add the mass of 1 hydrogen and multiply it by 12, because there are 12 of them. I would add 1 phosphorus, 30.97, and I would add the molar mass of oxygen times 4. So that's the math that would have gone into this question. That's how I got 149.12 grams per mole. Did anyone have anything that they wanted to ask about any of those 4 examples that you worked on yesterday? So we did this part first because to do any sort of calculation involving moles, you need to know what the mass of 1 mole is. Molar mass, just so we're clear, will be what we represent with a capital M when we're writing out the formula for calculations. And so when we get there, I'll say you can find the molar mass. It won't be given in the question. And I mean you need to do this, exactly this, the steps that we followed yesterday. So what we'll do today that's new is we'll talk about the formula that you use to calculate how many moles you have of something, or to calculate the mass of a certain number of moles. So yesterday, we were on this screen, and I said ignore what's at the bottom of the page for now. Well, that's what we're going to do today. We are going to talk about these 2 formulas and how we would go about using them. So we're still talking about moles. We already did that example. And you'll see that there are actually they're just 2 versions of the same formula. Mass is represented by lowercase m. Moles is represented by an N. And molar mass, a capital M. And the letters represent the same thing in the second version of the formula. The other thing that would be important for you to take note of is what unit everything is in. N is measured in moles, mass is measured in grams, molar mass is measured in grams per mole. So let's take a second. So the first thing that I'll say about these formulas is that if you look on your formula sheet, what you will see is this one. You won't see the other one on your formula sheet. And that's because they're not actually different formulas. It's the same formula rearranged to solve for a different part. And so the first thing I'd like to do is show you how to get from one version to the other so that when you're doing this on an exam, you can take that formula that's on your formula sheet and rearrange it. So if this is what I'm starting with, and this is what I want to end up with, I need to ask myself, mathematically, what do I do to rearrange a formula? Now, what we're going to do here is not just for this formula. This is for any formula, anytime, ever, in math, in any other course you take. We're going to do calculations in the biology unit. We're going to do calculations in the physics unit. And this same principle would apply no matter what type of calculation we're doing. So the first thing I would ask myself, if I have a formula that I want to rearrange, is what am I looking for? I'd like to take this formula and change it so that I can calculate lowercase m, which is mass. So I have to decide what is the thing that I want to isolate. Then, mathematically, I need to ask myself, how do I do that? I need to move anything that's on the same side of the equation as the thing that I'm looking for, so that it's all by itself. So I want to move capital M, and I can't just move it wherever I feel like. I have to do something that's legally mathematically. And so mathematically, I can change the equation as long as I do the same thing on both sides. So if I want capital M to go away, I'm going to make it cancel itself out. Since it's on the bottom of a fraction, that means I'm dividing by it. So if I multiplied, it would cancel itself out. That's good. So I just have to multiply both sides by capital M. The result is that I took this formula and I made that one. My result here is capital N times N equals lowercase m. That's exactly what that formula says. Now, what's on the left and what's on the right really doesn't make a difference because it's an equality. And so that is how you take a formula and you rearrange it. Does anybody have any questions that they'd like to ask about that idea? Now, some people find formula rearranging difficult because you're thinking about things that aren't real. They're just letters. And so what I like to encourage you to do is not to just think about the formula. I like to encourage you to think about the units that you are using. In my opinion, you don't actually need a formula to calculate the number of moles. You simply need to consider what units do you have and what units are you looking for. And so when we go through some practice problems today, I'm going to show you how to do the calculation without touching the formula. And the reason I'm doing this is, one, I think it makes sense for you to think about your calculation instead of just blindly following a formula. But two, as you continue on, this formula is nowhere to be found in the chemistry data booklet that you get in Chem 30. So eventually, you need to be able to do this calculation on your own without help. For Science 10, I don't care which way you choose. I just want to make sure you know that two ways exist. So if we're focusing on units, I'd like to show you how I could calculate something without ever considering the formula. The formula tells me that the number of moles equals mass divided by molar mass. And so I'm going to ask myself, how could I calculate the number of moles just by thinking about units. So we'll call this without a formula. The first thing you have to do is think about what unit do you want your answer to be in. So, if I would like to calculate a certain number of moles, that's the unit that I want my answer to be in. So I have to ask myself, well, what kind of units do I have? And how can I make those units cancel out so that only moles are left? If we think about what the formula says to calculate moles, you need mass and molar mass. And generally the way the question would be set up is that I would tell you I would tell you a mass in grams. You would find the molar mass using the periodic table, and you would calculate your answer. So generally, the second thing you would think about is what unit is given and what unit do I need. So in general, if I wanted you to calculate the number of moles, I would give you a number of grams. I would tell you that in the question. And so you would ask yourself, as the third step, what ratio do you know that exists between grams and moles? And in this section, it's always the same ratio, molar mass. So in this particular version, I would like to make a ratio where grams are on the bottom and moles are on the top. Why? Well, then grams and grams will cancel out. When something's on the top and then it shows up on the bottom of a fraction, it cancels itself out. Whenever we're talking about molar mass, the number that goes with moles will always be a 1, because it's always the mass of 1 mole. That's what the periodic table gives you. So all you need to fill in is the actual mass of 1 mole of that substance according to your periodic table. So I'll put in some pretend values here so that now you can see this with numbers. Let's say that I wanted to know how many moles there were in 18.02 grams of water. Now I picked a weird starting mass on purpose because it will make my answer easy to calculate. If you look on your periodic table, water's mass is 1.01. Or sorry, not water, hydrogen. In a molecule of water, I have 2 atoms of hydrogen. So I take 1.01, add it up. Water's molar mass is, not water, oxygen's molar mass is 16. So when I take those numbers together, I know that there are 18.02 grams for every 1 mole. Now I picked this on purpose so that my answer would be 1 mole, and it would be easy to calculate. But the idea is that if you know what unit you want as your answer, and you know what unit you're starting with, you just need to make a ratio that compares your starting and your final unit so that you don't ever need to worry about a formula or worry about rearranging a formula. Now, that's probably true for chemistry, probably not going to be true for physics if you continue with that, because some of those formulas are crazy. But all the way up to Chem 30, you shouldn't ever need a formula for anything. You could do all of your calculations just by knowing the units. So what we'll do now are a few practice questions to get ourselves used to how we use the formula. Before I do that, does anyone want to ask anything about either of the 2 basic explanations? So, where are we in here? There we go. So we're going to do a couple of calculations together of what I call stoichiometry. Stoichiometry is a fancy science word for comparing mass with number of moles. Yes? So if I go back to this example here, how did I get 1? The math that's happening when I'm using ratios is that I take this number, I multiply it by what's on the top of the ratio, and I divide it by what's on the bottom. So mathematically, I was doing 18.02 times 1 divided by 18.02. That's how 1 was my answer, because I was dividing the same number by itself. Does that make more sense? All right. So we'll do a couple of examples, and then I'm going to set you up with some more practice questions so that you can try using the formula yourself. Anytime I'm asking you a stoichiometry-related question, there are a few things that you should think about. Thing 1, what is it that I want? In the first example, the question asks how many moles, so that is what I want. What am I given? In this case, it tells me that I have 25 grams. And what substance do I have? Those are the 3 bits of information you need to know. What do I know? What do I want? And which substance am I talking about? Now, it would be my opinion that the first thing that you should do in a question like this is figure out the molar mass of the substance. That's capital M, that's grams per mole. There's no formula for this. All you do to figure out capital M is you look at the periodic table, you figure out the molar mass of each atom, and you add them up. So we already saw CO2 today, but just in case you'd forgotten, I would be doing 12.01, which is the mass of 1 atom of carbon, plus 16 times 2. That's because I have not 1 but 2 atoms of oxygen. That tells me 44.01 grams per mole. I'm not going to tell you the molar mass in the question. The only time I would do that is if it was an imaginary or unknown substance and there was no way that you could calculate it yourself. But you could assume that that's the first step that you'll need to go through when you're calculating things with this formula. Now I ask myself, what do I want and what am I given? I would like to know how many moles there are. So that means if I'm going to use the formula, this is the version I'm going to use. I want moles. Moles is the little letter N. Now, no matter which way you're doing the question, when I look at this and I'm marking things, I would like to see your work. And by work, I don't mean recopy the formula off your formula sheet. I can do that too. I mean, I would like to see what actual numbers are you using. So in this case, I would like to see that you used 25 grams and you divided it by 44.01 grams per mole. That's the work that I want to see. Now, someone I'm sure will ask me about how do I round my answer. And my short answer will be, in this unit, don't give me more than 2 decimal places usually in your answer. There would never be a need for that. When we get into the physics unit, we'll talk about the rules for how many decimal places you're putting. But for now, 2 is enough. 2 is plenty. So when I do 25 divided by 44.01, I get 0.57, which was actually 0.568, and then it kept on going. I rounded my answer up because the rules of rounding say if the number that follows is 5 or higher, you round up. I need to put a unit on my answer. And please, if it's a written question, circle your answer. Sometimes it's very difficult for me to see what I'm supposed to be looking at as the response. Now that's how this question would look if I was calculating with a formula. I'll show you briefly what it would look like if I was just concentrating on units. If instead of using a formula, I just asked myself, what unit do I want? What unit do I have? I would say I want moles as my answer, and I have grams. So in my ratio, I need something that has moles on top and grams on the bottom. The only ratio that we're going to discuss is molar mass. I know that it's always 1 mole. That's the definition of it. And then in this case, there are 44.01 grams for every mole. I know that I had 25 grams to start. So I would do 25 times 1 divided by 44.01. I would get the exact same answer. So I'm telling you, I don't care which way you use, as long as you show me the work that you did. Does anyone have any questions about the first example that they'd like to ask? So in the second example, we'll look for the same thing. What is the mass? That's what I want. Of 45 moles. That's what I know. Of sodium hydroxide. That's my substance. So I know that before I can calculate anything with that formula, I need to know the molar mass. So my first step will be to consider the formula for sodium hydroxide. The correct formula is NaOH. Sodium is +1, hydroxide is -1. Then I would look up on the periodic table and I would add up the mass of each of the atoms that you see. Sodium is 22.99, oxygen is 16, hydrogen is 1.01. This gives me exactly 40 grams per mole. That is my molar mass. So that's always the first thing that I do. Next thing I do is ask myself, what calculation am I performing? I'll do it with just units first, and then I'll do the formula second this time. I would like to know the mass. So that means I would like a certain number of grams as my answer. I know that there are 45 moles. So I ask myself, what ratio gets me from moles to grams? Molar mass is the answer. In this case, I want moles to cancel out. Whichever thing you want to cancel out goes on the bottom. So I know that I want my 1 mole to be on the bottom, and my mass, 40 grams, to be on the top. So mathematically, I would do 45 times 40 divided by 1. Now you don't have to type in divided by 1 on your calculator because it's not going to give you anything different than what you already have. So basically you're doing 45 times 40. It gives you 1,800 grams. If I was doing this with the formula, I would say to myself, I'm looking for mass, so I'm going to multiply moles and molar mass. So I'm going to take 45 moles and multiply it by 40 grams per mole. I would get the exact same answer regardless of the method I chose to calculate it.